What's going on, guys? My name is Devante, and today I'm going to be showing you how to read CSV files in Python with the Pandas library. So let's get started. Let's review some syntax. So as you can see here, you can read the CSV file by the read CSV method, and it returns a data frame. So you may be wondering, what is a CSV file? Well, a CSV file is basically a spreadsheet file that is delimited or separated by commas. So I'll show you an example. So as you can see by this file, this is a CSV file, and it looks like a regular spreadsheet file, except it becomes very obvious when you open it in text editor. And you can see here, all the data elements, all the values are separated with commas, hence the name, comma separated values. So how do we use this? Well, the most simple usage is to read it with a URL or a path. So for example, if you take this right here, this is the same file we just viewed, the Ukraine sanctions file. And just note the Pandas library. This is an alias for Pandas, and I forgot to import it, so I'm going to import Pandas as PD. And we can literally just list the URL. The URL can also be a path. So let's see what we get. So here we go. Just like that, your CSV is read. I mean, it's not perfect yet, but there's a bunch of parameters you can use to get exactly the data you want. So similarly, we can also specify a file path. So this is saying that I want to move up one folder, and I want to go into the datasets folder where my CSV file is found, and I just named the CSV file. And this is a relative path, so it's relative to the current working directory that I'm in. And right now, I'll show you the working directory I'm in, which is in here. I'm in Jupyter Notebooks. So I want to move up one directory, and I want to go into the datasets folder, and I want to open this CSV file. Just like that, you get the same result. If you're planning on moving from a Linux system to a Windows system and then back, for example, you want to make your code the most portable it can be. So to do this, you want to use the OS library, for example. So we can import OS, and what we can do is basically define a file path that can be used on any system. So we say file path is equals to os path.join, and we're literally joining all these folders and file names together with that system's file path delimiter. So as you can see here, on Windows, it's denoted by a backslash, but on Unix-based systems, it will be a /. So you do this, and as before, you name your data frame, PD, and it's equal to p.readcsv, and you can put your file path within it. And there you go, same result. Now, what if you're met with the situation where your CSV file is not actually comma separated? Maybe it's semicolon separated, like the following file. So you can see this file just looks like a mess because it is colon separated, it's not comma separated, and all the data is found within one cell. And you can see there's the semicolons, 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 everywhere you see semicolons. But that's no problem, we can still read it. So all we have to do is say our data frame, I'll call it EU because that was an EU European sanctions file, equals pd.readcsv, and we can define our URL, and we can define the keyword argument and pass a string with our separator. So in this case, it's a semicolon. Don't worry about this warning right here. I'll show you how to fix this in a second. There you go. About 12,000 rows, over 100 columns. That's that easy. Now, what if your file doesn't have any headers in it? You can see this file had headers. What if it doesn't have headers, such as the following file? So if we go to this site, this is the US Department of the Treasury, which is the OFAC sanctioned site. And we can see they offer a bunch of different file formats. If we click on the CSV file, it will bring us to here. And we can see it's literally just data, all data. There's no headers whatsoever. But they also provide a specifications, that specification right here, which will bring up this. And you can see all the column names we need, which is perfect. So all we need to do is name them. So I typed that before, so that wouldn't take long. We could say OFAC equals pd.readcsv. We name our URL or our local file path, and we specify header equals none. You should always specify this if you know your file does not have a header. And also name in a list all your column names, just as before. So what will this give you? Well, you now have your CSV file read into a data frame. And there you go. Now you have your header. What if you wanted to define another index? So you can see here that we have an integer index, which is the default index. What if I didn't want that? What if I wanted to say SDN name is my index? Well, it's as easy as passing the keyword argument index underscore column, as you can see here, oops, is equal to whatever column name we want. So what will this give us? It gives us a data frame with the index column set to our column that we specified. Now, what if we wanted to only parse a certain subset of the columns of a CSV? Well, there's a parameter for that too. We can simply do the same as before, p.readcsv, our URL, and we can use the useColumns keyword argument and pass a list of the columns we want to return. So let's say I wanted only SDN type, SDN name, and program. You name them inside of a list. And just like that, you have the entire CSV, but we only parsed 3 columns. What if we had something similar, but we only parsed 1 column, and we want to force the object returned into a series? Well, we could use the squeeze keyword argument. So we say, I want to use only 1 column, so I only want to return 1 column in all the rows, and I say squeeze equals true. This will squeeze it into a series instead of a data frame. So you can see here, now we have a series. We can check that we have a series by doing type of our object, and we see it's a series. And we can also do is instance, name our object, and we want to check what type it is. It is in fact a series. What if we wanted prefixes on our column names instead of a default integer column name? Well, all you have to do is use the prefix keyword argument, and we pass in a string that you want to have as a prefix. So this will give us column underscore and then our integer, which is the place of our column. So we have column 0, column underscore 1, all the way to column underscore n. Just like this. If we had duplicate columns in our CSV, we could mangle our duplicate columns by forcing Pandas to parse it with a integer suffix. So for example, if we had two of the same columns, add just one, let's save it. We could read it in and pass the keyword argument Mangle duplicate columns. This is by default already true, but it's always good to be more explicit to show others that are reading your code exactly what you want to do. Now let's filter our columns so we can see what we got. So I'm going to use the filter method for data frames to say I want all the columns where the name is like address. So you can see right here, our two duplicate columns are present, except our second duplicate column will have an integer appended to it. Now, what if we wanted to specify a data type, a specific data type for a set of columns or a specific column? Well, we could use a dtype keyword argument, such as the following. So we have, for example, a group ID in our Ukraine data frame. Let's see. So we have group ID, and we want to force it to be an integer. So right now, we can see our dtypes of our columns. Our group ID is set to integer 64. Well, let's say I want to set to integer 32 to take up less memory or whatever other data type I want to set it to. Well, we can just name it in a dictionary. We name our column name in dictionary as the key and our data type to be the value. And by default, this integer is going to be integer 32, which means a 32-bit integer. So we can check our dtypes again. Actually, just run this code. Right there, it switched from integer 64 to integer 32. What if we're met with a situation where we can't read our CSV file and we get a Unicode decode error? Well, your first instinct may be to try to specify a specific type of encoding, which may work, but if it doesn't, you can also specify an engine type. So we have two types of engines for read CSV. We have the C engine and we have the Python engine. The C engine is typically faster, but the Python engine is more feature complete. So what you can do is let's read in this UK HM Treasury sanctions file, and we're going to take away the engine type, which will by default be read with a C engine. This will give us a Unicode decode error. So what may work for us is specifying the engine as Python. And you can see no error. And there you go. Here's our file. As you can see from this file, our header got read with our data, and which is what we don't want. We want to separate our header and our data. Let's show you what the actual file looks like. So here's the file, and you can see right away why Python or Pandas assumed that our header was a part of our data, because we have this garbage row right here. We don't want this. So what you want to do is skip it. Just easy. All we have to do is define the skip rows keyword argument to be the amount of rows we want to skip, or this can also be a list with the index locations of the rows we want to skip. So we can either put 0 within a list, and what also give us is what we want. So now our header is separated, or as before, we can put the amount of rows we want to skip. Either one works. And there you go, same result. Let's say we want to skip a certain amount of lines or rows at the bottom of our CSV. Let's say there's some garbage data that we don't want, and you want to skip it. Just as before, we can specify not skip rows, but we can specify skip footer. So this is the amount of lines that you want to skip from the bottom of the file. So let's say I want to get rid of these two rows. Just like that, those two rows that we had are gone. And it starts from here. Now, what if we want to specify only a certain amount of rows we want to read or parse from our CSV? Well, there's a keyword argument for that. It's called nRows. So this file right here, it has about 9,000 rows. And you can see this by this file right here, over 9,000 rows. And we want to only read 100 rows, for example, or how many rows you want. So you specify an integer with the amount of rows you want. We can check the shape, which is basically the dimensions of our data frame with dataframe.shape. So this will return a tuple of the amount of rows we have and the amount of columns we have. Before we had over 9,000 rows, 29 columns. Now we have only 100 rows, just as we specified, and 29 columns. Now, what if you're met with a situation where you have some value or some string that you want to be represented as an NA value? So let's look at what we mean. We look at this OFAC sanctions file, and we can see we have some weird character at the bottom of our file. We don't care about this row, we don't care about this character. So what we can do is specify it in the NA values keyword argument. So what we're going to do is simply copy and paste it. And for some reason it's represented like this dot, but it's not actually a dot. That's just how it's represented in here. And we see at the bottom of our file, I should say, we have now an NA value. Before, when we didn't have this, we still had that character. But with that, now it's an NA value. And what we can do is simply drop it. So you're going to say our data frame dot drop NA. And which way do we want to drop it? Well, we want to drop any row where all the values are NA. So by default, the axis is the index axis. So it will look this way to see if every value along the row is NA. And there you go. We no longer have that bottom row. Let's say we want to parse date columns as a certain data type. So let's say we have our UK HMT dataset, and we have these two columns, which are dates. Well, we can just parse them while we're reading the CSV with the parse dates keyword argument. Right here, we have parse dates, and within a list, we name our column labels that we want to parse as datetime objects. So we can check our data types, and now you can see they're datetime objects or datetime data types. Now let's say we had a data frame with a date column and a time column, and you want to combine these two columns into a single column. How could we do this? Well, first we can define our data frame, and we have a date column with two dates. We have a time column with two dates. Let's see what it looks like. So here we go. And let's write it to a CSV. So now we literally have a CSV with our data in it. And now we can read it back into a CSV by reading it with a read CSV method. And in the arguments, we can specify our part states argument. Now, what this is going to say is I want one column, dt, that is a combination of our dates column and our time column. And I want to keep the date column. So I want to keep both of these columns within our data frame. It will also give me is a data frame with now 3 columns, and we kept these 2. If I were to remove this, the keep columns keyword argument, now you would only have our DT column. And we can also check our data types of this CSV. So we go df CSV, D types, and you can see our DT column is now a datetime column, while our other ones are simply objects. Now let's say we want to change the data types of our dates column and our time column into datetime objects. Well, we can use the toDateTime method from Pandas. So what we can do is pd.toDateTime, and within it, we can pass our column. So we can say df CSV, and let's say we want to convert the dates column into a datetime object. Now you can see its data type is datetime. Let's say you're dealing with really big files, maybe gigabytes in size, and you want to read it with the read CSV, but you don't have enough RAM to read it all at once. Well, what you can do is chunk it into separate chunks and then make a data frame out of it. So how do we do this? Well, we use the chunk size argument, and this specifies the amount of rows we want to read at one time. So we want to say we have a list, which is where we're going to append our chunk. So we're going to have chunks of data, 200 rows each, and we want to append each chunk into a list. And at the end, we're going to concatenate or put each chunk below each other, which will make a data frame for us. So if we run this, you can see that our last chunk was 180 rows because we didn't have enough rows to have 200, but you can see that our UK CSV is now actually a CSV. There we go, over 9,000 rows. The last keyword argument I'm going to show you guys with read CSV is decompression keyword argument. So this is useful if you have a compressed file and you don't want to extract the file. Maybe you want to just read it straight from the archive. So what you can do is name the compression keyword argument with the type of compression that you're dealing with. So let's say we make a compressed file. So let's send this to compressed folder. And you can only have one file within this compressed folder, or else it won't know which file you want to read. So all we have to do is name our compressed folder. And you can also infer this. You can also say, Pandas, I want you to infer which type of compression it's using. So you can also say infer, which is its default behavior. So now, there you go. You read in your CSV. And the same works if you explicitly named your compression type. The same thing occurs. And that's all I have for you guys for today. If you guys liked the video and it helped you guys, leave a thumbs up. If you didn't, leave a thumbs down. And be sure to subscribe for more programming tutorials. I'm out. Take care.